Hello, welcome to another Midnight Maths video. In this one, we will be talking about trig. And I'm gonna assume in this video that you have some knowledge about like what the trig functions are in terms of the unit circle. If you don't, I'm gonna link a great video by Khan Academy in the description that'll sort of introduce you to this idea of the unit circle. But uh, in this video, I want to take it a little bit further and explore some basic variations of trig functions, or as they call it in math, transformations of these trig functions. So let's get started here. So this is, I've sort of drawn like the typical intro to trig unit circle diagram, where this red arrow represents like the main line that's theta degrees from the positive x-axis, right? So as a review of angles, you always start with a positive x-axis. We say that this that this whole thing is the plus x-axis, okay? And notice that we do not put arrows at the other side. Now, I know probably before pre-calc you may have put arrows there, but at a certain point we just don't, because uh, there's a positive side of the axis and we want to indicate that. So we put just an arrow on one side indicating the positive x and positive y axes. So as you're more familiar with, this is plus x and plus y. And now angles start with the plus x axis and then they go counterclockwise theta degrees. Now this is very analogous to, I want you to keep the linear analogy in mind. So if you have a line, let's say you're on a swimming pool, okay? So you start at the edge. So you start, that's maybe a little bit, so the edge is 0 meters, okay? And then 10 meters from the edge toward the other edge is 10 meters. Notice I put this, if we're saying that direction is positive. I could put the arrow right here and say that direction positive. So you're 10 meters away from the edge right here, right? So this is a swim lane. Now, if I tell you swim plus 10 meters, you're going to swim this distance, which is going to be 10 meters. And then you will arrive at this other point, which is 20 meters away from the edge, right? Fair enough. And if you swim minus 10 meters from this point right here, the 10-meter line, let's call this like point A. So swimming 10 meters from point A gets you here. Minus 10 meters from point A gets you back at the edge of the pool, right? So minus just means go back the other way. Now, over here, we've got angles, right? So a certain angle theta, as long as you say it's positive theta, you're going to go around that many degrees counterclockwise, where we define counterclockwise as sort of the forward direction, just like over here, how we define rightward to be the forward direction. In math and angles, the counterclockwise is the forward direction, okay? So we can start by first doing some rename, okay? So instead of theta, let's call this t. Why do we want to call it t? Well, first of all, t is not a Greek letter, so maybe it's less intimidating to you. Also, t usually represents time in math. So that's how the way I want you to sort of think about this unit circle is in terms of time. Imagine this arrow is just rotating at a constant rate around the unit circle. Let's say it's at a specific rate of 1 radian per second. So here I'll sort of mark what the radian measures are at different points of the unit circle. And I'll also mark the degree equivalents of those, because I do know that a lot of people, a good amount of people are like more comfortable with degrees than radians or whatnot. So I'll include both. But this is the usual unit circle, right? And then you come back around and you're at 2 pi radians. So in degrees, this is 0 degrees or 360 degrees. Then here we're at 90 degrees. Then here we're at 180 degrees. And then you're at 270 degrees. So I've taken time to write this down because it's very important for you to have these 4 markers in your head. Ideally, you want them in both radians and degrees, and you should be comfortable going with both. But especially in math, you're going to be working with radians usually a lot more than degrees. So here we say, let's say 1 radian per second. So what does that mean? So that means it takes 2 pi seconds for this line to rotate about the origin. So it starts right here at 0 radians, and then it sort of rotates. It goes around. And pi over 2 seconds later, it's over here. And then we go around, and then pi seconds, and then you keep going, right? Keep going. And then 2 pi seconds, you're back where we started, and then we keep going round and round and round again. So one thing to consider is, let's consider sine of 20 degrees. Okay, what does that look like? What does that look like here? Well, what I'm going to do is copy this circle, and we're considering sine 20 degrees. What does that look like? So we go over here, 20 degrees, maybe not that big of an angle. This is 20. And sine is the y coordinate, which in this case is this coordinate. You could say it's this, right? It's all really the same length, just wherever you draw it. So this length right here, this, I don't want to say length, the y coordinate, because lengths are always positive. So this is sine 20, okay? So now, okay, we don't really know what the value of sine 20 is, and that's okay. The unit circle, it's often associated with, oh, let's find exact values for certain angles, and let's just sort of define the trig functions, and then after that, it's sort of just like left alone most of the time. But we can understand trig functions at a deeper level if we go geometrically with the unit circle and not just use it for like specific values. So we can consider, okay, sine minus 20. What's that? So sine minus 20 can be like this, okay? And you got a minus 20 over here. And now you're going the same amount. So just like in the swim example, we're getting set minus 10 and 10. They are, sure, they're different directions, but it's the same amount in each direction, right? So that means that this point at 0 meters and at 20 meters, they have a special relationship to the place where we started, point A, where if you sort of reflect this point, the left point, across the line I've drawn, the dotted line, you get this right point. So in that way, they're a sort of mirror opposites of each other. And it's the same thing when we're dealing with angles, except now the relevant line is this line, but it's really the same thing, because this line, why am I drawing this line particularly, is because it's the 0, the starting point, right? In the swim example, the starting point happened to be 10 meters, so I just drew a line right there. But over here, the starting point is the positive x-axis, so you draw the line on the positive x-axis, and this point, right? Same deal. You reflect this top point across the dotted line, and you get the bottom point, and you reflect the bottom point, you get the top. So that means that this sine coordinate is sine minus 20. Okay, so that's interesting, right? Because you know that these two have the same length, right? Like sine 20 and sine minus 20 have the same length. It's just that they're opposites of each other. They're opposites, right? So you say that sine 20 degrees is the same thing, almost the same thing as sine minus 20 degrees, except you have to put the minus sign here because we are saying that these two are opposite, right? Now this holds true for any value of t. Sine t is minus sine negative t, and sine has this specific property. We say sine is an odd function. Okay, now let's consider this for a moment, because what we did right here, okay, it was a sort of mathematical sleight of hand, if you will. I just said, okay, these are negatives, and then to set them equal to each other, I just said, okay, you just put a minus sign to deal with that because they're negatives. So I went from the geometric to algebraic representation, and we handled it all there. But we can also just stay here in the unit circle. So what I mean by that, what I mean is, unfortunately, we've got to draw another one to really do this. Okay, now, this was 20 degrees from the positive x-axis, right? And we said this was sine 20 degrees. Okay, so now let me ask you a question. What is negative sine 20 degrees? Just based off of, like, not what is the exact value, but what does it look like on this unit circle? Well, sine negative 20 kind of, it looks like this, right? So so what negatives mean in terms of this, okay, is we're going in opposite directions. So in this case, the sine, you're talking about the y coordinate, okay? So if it's sine 20, you've just thought, okay, in this case, sine 20, it's a positive y coordinate, okay? So minus sine 20 is we just flip it. We flip it. So you say this is minus sine 20 degrees. Now, if it was cosine, it would be different. You'd flip it across the x direction because that's the direction the cosine operates in, right? It's only along the x-axis, right? So here we can say, okay, so we flipped it. But hey, wait, isn't that the same thing as what we did over here? It's the same. Isn't this the same arrow? This guy, the same arrow as this. And you'd be perfectly right. That's exactly what we wrote right here. Because basically you're saying this now these two, I want you to understand there's a slightly different, like, compared with the minus sign negative, there's a different geometric interpretation we're dealing with here. Like this one, we're saying, okay, just flip it. That's what minus sine 20 degrees is. And this over here, now we said sine minus 20 degrees. So what we did in this one is we literally rotated the line minus 20 degrees, and then we projected it across into the y-axis, and then we got the sine. This is what we do for any. We rotate it by x degrees, t degrees, or radians, and then you project it onto the y-axis. So in this case, it was 20. So in this case, you minus 20, and then rotate it here. But here it was different. We didn't rotate minus 20. What we did, we rotated 20 plus 20. And then we projected on the y-axis. But then we said, okay, well, negative. So minus means flip. Just like in distance, minus means flip direction. So we did the same thing. So we flipped direction. Now, these two things, even though they're different geometrical operations, transformations, so to speak, this and this, they happen to give us the same result because our circle is really symmetrical. That's one thing you'll notice in trig. There's a lot of symmetries with this unit circle, and trig is really all about sort of unpacking those symmetries, if you will. So in this case, we say, if we say that is the same as this, we say sine minus 20 degrees equals minus sine 20 degrees, which is basically what we wrote here, except now the minus is attached to this guy. You can move this minus sign over here with some algebra, right? You just multiply by -1. So yeah, these are equivalent statements, essentially. So all of that was just for sine minus t and minus sine t. basically there's a counterpart for cosine t and cosine minus t, and I want you guys as an exercise maybe to figure out what the relationship is between the two cosines. Really, all you're going to do is the same as the sines, except you're going to work in the x direction instead of the y direction. It's really helpful to have this analogy in mind, where minus means flip along that direction that you're going. So minus means flip along the y direction in this case. Now, in future videos, I hope to unpack other transformations of trig functions. In future videos, we'll look at some even more interesting ones. Like, for example, we'll look at sine omega t, and where omega is some number. So we say sine 3t, for example. What does that mean in terms of the unit circle? Or we can look at a sine t, where a is just some constant. So what does this do to the sine function? And we'll look at a few more. So hopefully I'll see you guys in videos to come. We have a lot to talk about with these trig functions, and so I'll see you guys in the next one.